Dear students, now we are going to start our new lesson, that is circles. In this lesson, we are going to learn about tangent and its properties. Introduction to tangent and its properties. Now observe the figure. There is a circle and a line PQ. Observe this first figure. Observe the relationship between the circle and the line. Observe the second figure. There is a circle and the line PQ. What relationship do you observe between the circle and the line? Now observe the third figure. There is a circle and the line PQ. Observe these three figures. In this first one, a line is little far away from the circle, means there is no common point for circle and the line. In the second figure, the line touches the circle, and in the third figure, the line intersects the circle. In the first figure, the line PQ and the circle have no common point. There is no common point for circle and the line PQ in the first figure. Observe the second figure. Only one point is common to the line PQ and the circle. Observe that common point. In third figure, 2 points are common to the line PQ and the circle. In the first figure, PQ is called a non-intersecting line with respect to the circle. In the second figure, PQ is called tangent to the circle. In the third figure, PQ is called secant to the circle. In this lesson, we are going to learn more about tangents. Tangent is a line which touches the circle only at one point. So this is about non-intersecting line with respect to the circle, tangent and the secant. Now let us learn more about tangent. Tangent to a circle is a line that intersects the circle at only one point. A line that intersects the circle at only one point is called tangent. Now there is a circle. Now this is the tangent. This is the tangent AB. Observe that the line intersects the circle only at one point. Name that point as P. Now line AB intersects the circle at point P. P is called the point of contact. The common point of the tangent and the circle is called point of contact. In this figure, P is the point of contact because P is the common point for tangent and the circle. Now, observe this figure and mark a point on the circle. Now, you have to draw line. You have to draw lines passing through this point. Draw lines passing through the point P. Now let us draw lines. See, these are the lines passing through the point P. You can draw so many lines passing through the point P. But out of these many lines, there is only one tangent at a point of the circle. Through the point P, we can draw only one tangent and remaining all secants. So remember, we can draw only one tangent through a point on the circle. If a point lies on the circle, then we can draw only one tangent. Then the remaining, all the lines will be the secants. Observe the figure. Secant touches the circle. Secant intersects the circle at 2 points. So, tangent to a circle is a special case of the secant when the two end points of its corresponding chord coincide. When two end points of corresponding chord of secant coincide, then it becomes a tangent. Now see here. Now observe the line. This line is the secant, and observe the corresponding chord. See the corresponding chord of the secant. Now next line, see there, observe the corresponding chord of the secant. Now observe the third line, observe the corresponding chord of the secant. Observe the length of the chord. Length of the chord is decreasing. See there, length of the chord is decreasing. When the two endpoints of the chord coincide with each other, then the secant becomes a tangent. When two endpoints of the corresponding chord of the secant coincide, then the secant becomes a tangent. So, tangent is a secant when the two endpoints of its corresponding chord coincide. See, there is only one tangent passing through a point P. When the line moves to the right side, the length of the corresponding chord of the secant increases. Length of the corresponding chord of the secant increases. When you move leftward, the length of the corresponding chord decreases. The word tangent comes from the Latin word tangere, which means to touch, and was introduced by the Danish mathematician Thomas Finacke in 1583. Tangent is a Latin word from the word tangere, which means to touch, introduced by the mathematician Thomas Finacke. Now observe this figure. This is a secant. PQ is a secant to the circle. Now draw parallel lines to the secant PQ. You can draw so many parallel secants to the given secant. But how many of these lines are tangents? How many parallel tangents can be drawn to a secant PQ? How many of these lines are tangents? Only 2 tangents can be drawn parallel to a given secant. Only 2 tangents can be drawn parallel to a given secant. If secant is not given, we can draw so many parallel tangents, but for a given secant, we can draw only 2 tangents parallel to a given secant. But remember, in a circle we can draw so many parallel tangents. Now, number of tangents to a circle. Now, there is a circle. Mark a point P on the circle. Now, how many tangents can be drawn through a point on the circle? We can draw only one tangent. See here. Now the point is on the circle. Now draw tangents through the point. Now mark a point inside the circle. How many tangents you can draw? You can draw so many lines, but how many of these are tangents? There are no tangents, all are secants. Now take a circle and mark a point P or any point outside the circle. How many tangents can be drawn from a point outside the circle? 2. So if a point on the circle, there is only one tangent to a circle passing through a point lying on the circle. There is no tangent to a circle passing through a point lying inside the circle. If the point lies inside the circle, then no tangent to a circle. There are exactly 2 tangents to a circle through a point lying outside the circle. On the circle, only one tangent. Inside the circle, no tangent. From a point outside the circle, 2 tangents. Remember these 3 cases. Now, observe this, there is a circle and there is an external point P. Now draw tangents from P. We can draw 2 tangents from point P. We can extend tangent to any length. Now mark the point of contact. Point of contact is the point where the tangent touches the circle. Now A and B are the point of contact. Now observe the line segment from P to the point of contact, that is PA, and here PB. Observe the length PA and PB. This length is called length of the tangent. Length PA and PB is called length of the tangent. The length of the segment of the tangent from the external point P and the point of contact with the circle is called length of the tangent from the point P to the circle. The distance PA and PB is called length of the tangent. Length of the segment from the external point to the point of contact is called length of the tangent.